Today it's my pleasure to introduce Carolyn Maher. She is Professor of Mathematics Education and the Director of the Robert B. Davis Institute for Learning at the Graduate School of Education at Rutgers University in my home state. Her research has focused on the development of mathematical ideas and mathematical reasoning in school children. Most extraordinary is her longitudinal study, now extending over more than 2 decades, that has followed the mathematical learning and thinking of a cohort of working class students from when they were in grade school in the 1990s to their lives today as young adults. For me, Maher's extensive video documentation of that cohort brings to mind Michael Apted's famous Up series in terms of giving us really an extraordinarily unique longitudinal look at how people grow up in modern math societies. Maher's groundbreaking work in her study demonstrated the capacity of even very young children to engage in mathematical argumentation and mathematical proof-like activities. Very importantly, her work is focused not on raising scores on standardizing tests, but on fostering the human capacity for critical reasoning and critical thinking. Clearly then, Maher is someone who appreciates the deep and human beauty of mathematical thinking. With a new grant from the National Science Foundation, Maher and her colleagues are now focusing on teacher education and on how careful study of video recordings of children's learning can help K through 12 teachers do a better job teaching other students mathematics. Professor Maher has published over 60 referee journal articles and book chapters. She's the editor of the Journal of Mathematical Behavior, as well as the co-editor of the recently published 2011 book, Combinatorics and Reasoning, Representing, Justifying, and Building Isomorphisms. I'm very pleased that with her visit here today, the Monroe Center is extending our semester-long inquiry into schooling in math societies into the important area of mathematics education. Carolyn Maher's talk today is titled Mathematics in Schools and the Demise of Reasoning. Please join me in welcoming her.
And it's really a pleasure to be here, and I'm honored at being invited to be a part of this wonderful series, and a pleasure to meet your students and be able to engage with them earlier today. That was really wonderful and a lot of fun. So let me begin by maybe making reference to the title, which talks about the demise of reasoning. And I want to suggest here that there isn't much reasoning that is taking place in public school pre-college education today. When you look at scale and you look at the influence of other movements, there doesn't seem to be much room for reasoning. And I speak also from the experience of having been a former teacher in the public schools in my younger days, where I taught high school for some time, where it was fine to become creative as a teacher and to not be restricted to very rigid requirements and paces and ways of moving within the curriculum, and being encouraged really to create new ways of engaging students in their mathematics learning. And somehow something happened between the 60s and the 70s and into the 80s where there became less and less room for the thoughtfulness and the fun and the enjoyment of creative learning of mathematics. So I've observed that, and in some ways really don't recognize from my own teaching experience, and I've taught in the public schools for 7 years, it seems very alien to me today, some of those conditions, as I listen to my own students tell me about some of the conditions under which they are teaching mathematics today. So bearing that in mind, and bearing my early experience, and you can go back more in history to trace some of this, I obviously have concern, and as I noticed, Dan and the students have concern about that kind of practice in school of learning and of teaching mathematics. And so I come here today to share the work that I've been doing over the last 2 decades and the current work I'm doing to suggest that perhaps maybe there is an alternative. Maybe so. So I'm going to, in this talk, deal with 3 major ideas. The first, I'm going to discuss the background of my work so that it can be set into the context of my own research with my own colleagues who are mostly my graduate students. This involves the studies I've done over the years, both longitudinal and cross-sectional, about the development of mathematical ideas and ways of reasoning in students. And then finally, I want to talk about our current work, which involves partnerships with university libraries at Rutgers and the University of Wisconsin, a collaborative, which establishes the construction of what we call the Video Mosaic Collaborative. And I am so impressed by your facilities here that I'm going to be able to get online to show you this in real time. So I'm going to move from my prepared PowerPoint and make some changes here. So what I'm going to be talking about, what this VMC is, how we're using it, what we've learned so far, and what are some of our challenges and plans for its use in the future. Contextual issues and background. What are some of the roadblocks? What are some of the roadblocks that get in the way with the importance of encouraging reasoning in students? Well, you know, in the United States, we know that teachers' education is not lifelong. Teachers' education continues if they choose, if they want to do graduate work. There are exceptions, you know, but by and large, even if you take New York as a state, they require a master's degree for certification of those teachers. They go back to school for 3 years, but it's not lifelong. When you compare it to other countries where the actual teaching and collaboration and learning about learning is lifelong. So this is a problem because many of our teachers are isolated. And not only are they isolated, they really are subject to the newest idea that comes about in their school that is of some popularity of the time, and they're supposed to buy into this idea, and then someone else comes in with another idea and another idea, and I think they become cynical, and maybe not as engaged as one might want them to. A trend in our country is the movement of administrators. Administrators tend to stay in a school district for a while and they move on. They move on to positions of other advances in their careers. That while they're working in their particular schools and districts, they have an agenda that will hopefully enable them to move on even and do greater and better things. They don't build on earlier agendas that are solid and good, but there's a lot of change, and that movement of administrators is problematic. In our own state, there is a very severe shortage of superintendents of schools. No longer do superintendents of schools in our state have the option for tenure. There isn't such a thing as tenure anymore. So this is problematic. The investment, you know, staying, of job security, and being influenced by public demands that may really not necessarily be based on important educational and solid ground. Limited resources, well, we know about that, and we know it's only going to get worse, right? That's problematic. It's problematic because, remember, teaching is not lifelong learning. The amount of professional development that can happen in schools is a negotiated commitment of time, and how that time is spent is for professional development is decided by administrators, and it becomes even more complicated for those teachers who teach a variety of subjects in elementary schools where they have to be specialists in so many things, and they have to use professional development time to grow and learn in many areas other than mathematics. There aren't too many images of best practice. I mean, we have ideas, we think we have ways of improving learning and teaching in many content domains, but we don't have those images. When I say those images, I think this is important because what I hope that I'll be able to show you is our wonderful collection of images of good practices and evidence how students can think and reason and collaborate well. And I think these are images that could have, with appropriate use, good opportunity for the advancement of professional development of teachers. And you don't have to go to meetings, you can just go to a website and you could study these and use these to grow as an independent lifelong learner. So this idea of lifelong learning opportunities is an important one, but it isn't necessarily going to take place within particular school districts and environments. You can't count on that. And so what can we offer the very serious educator who wants to learn and grow and become better at what he or she does? There is a perspective here, and depending upon your perspective, you could obviously, your assumptions could lead you to different conclusions. So when we talk about learning of mathematics, what do we mean? Well, do we mean building meaning of mathematical ideas? Or do we mean some kind of rote procedure that involves symbol manipulation? Where manipulation is something you're told how to do it, and you're told what to do, but you don't know why you're doing it. And even if you're told why, you still may not know why. In other words, the meaning is not your meaning. It's not meaning that makes sense to you. It's the sense of sense making. And the learning also traditionally has been very individual. It has been isolated. And so this notion of learning communities and learning as a community is a perspective that I hold as extremely important. This building of community is very, very important. I think it's not only important in schools for pre-college education, I think it's extremely important for undergraduate and graduate education. I think it's those communities that you can learn and you can feel safe and you can feel empowered and you can feel that you could make a contribution, you can make a mistake, and that mistake is not going to be costly, that people are listening to your ideas and they're listening in a way so that you can learn together. So in our work, we have established the importance of sense making. Sense making is extremely important. We expect our students to make sense of the work they're doing in mathematics. And this notion of sense making we take as a cultural norm. We find it to be very important. And that if one has made sense and one works to make a solution to a problem, we have learned to ask students to justify that solution. What convinces you? Can you convince us? Can you convince each other why we should accept your solution? This notion of being able to justify and convince is extremely important, and we have found that in that process of coming up with a justification or convincing argument, that a certain kind of reasoning is exhibited. And what's very exciting to me is that reasoning becomes proof-like. It takes forms of proof. So the justification is also to convince yourself and others, and by others it's not the teacher. It's to convince others who are part of your community. Our work started before the large reform that has taken place in mathematics education, as represented by the National Council of Teachers of Mathematics and all of their standards that they have suggested for the improvement of mathematics education. We actually began our work before the standards, but our work is consistent with the standards. We find that what the standards advocate are very, very compatible to what we think is important for the kind of learning we like to have take place. So a little bit about our research. This is sort of background. We can talk about, we're very fortunate, our group, in that we have had excellent funding over the years from the National Science Foundation as our main funder. And there are other funders as well, but they are a primary funder. And that's been very good because we've been able to continue and build upon what we've learned. And that's been very important, to have that continuity over the years. But we started our work without any funding. And if anyone looks at our old work or the videos we've made, they really are rather primitive. You would probably enjoy looking at them because, even the microphones are in little cups, and the students are tapping them away. And we have, we had cameras initially that were not professional cameras, but, they sort of did the trick for us. We wanted to be able to follow students' reasoning and thinking and how they work together. But we started with classroom-based research, and our classroom-based research that has the greatest longevity is following a group of students from the first grade. They were randomly selected from the first grade. Well, because there were 3 first grades and students were randomly put in 3 classes. So that's my definition of randomly selected. We were able to work with those children for 3 years. Our 4th year, when we had our major funding from the National Science Foundation, the students were dispersed to different classes, and it was hard. We couldn't follow the whole class. It was trickier to do. But our longitudinal study, we followed the students all the way through elementary and high school. It was the class of 2000. And that class of 2000 now, as you can see, they are out of high school now for 11 years. They're out of college. They're out of graduate school. Some of them are in doctoral programs, working on advanced degrees. Some are working in a variety of capacities. And that's a whole other talk to tell you about them. I'm still following these students. I find it very interesting, and there is still a lot of work being done by my own graduate students in following their mathematical reasoning and thinking by studying their videos over the years and the related data. But our studies, what's really important is that when we started in our working class community with our work, when we negotiated with the National Science Foundation for funding, we had included an urban community, New Brunswick, as a partner in this research, along with the original group of students at Kenilworth. And NSF came back and said, you don't have a privileged group in there. So we said, yes, we don't. We think you should have a privileged group in there. Can you get one? Now, you know, it all sounds wonderful. And they said they'll give us more money. Those were the good old days. And it all sounds wonderful, but imagine that the work you were trying to do gets increased considerably. You know, it's a lot more work to follow the groups in the different settings. But we said, of course we could. Right? Of course we could. You could give us more money, and we. Now, why would they ask that? Think about why would NSF want us to work with a privileged, suburban group of students? And what they said is, you know, whatever you do, whatever you find, what you learn, the more privileged students communities are going to think it doesn't apply to them, and they could keep on doing what they're doing, which is really accelerating students quickly and fast through programs without necessarily a lot of understanding. I thought that was pretty insightful of the program officers of the time. And we have extended our work in recent years to an informal after-school program working with middle school students, 6th, 7th, and 8th grade, and that work was enriched by new tools we had and new technologies. And that work is still being analyzed, and there are several dissertations that have come out of that work. So that was in response to the question, well, you can't start doing this now with every student from grade 1 and 2. You know, we have problems now in our middle school. We have to start later. So we said, well, okay, we'll start in our middle school. Let's see what we can learn and what we can find. And that's precisely what we did. And we went to the urban community of Plainfield. And we accepted any student. We had students who were way behind grade level in math, and we took anyone who really was very interested and wanted to come, and that was really very exciting. That was a 3-year study. So we have done work, and we've extended it to other groups, but what does all this work mean? When we first worked with teachers, we worked with administrators. That was very important. The administrators had to buy in. They had to buy into what we were doing. They had to make certain conditions possible for us to do what we were doing. And those conditions were very important to us because when we first started, if mathematics were taught at all, it was not taught longer than a half an hour. And then when they moved to 45-minute math periods, they thought that was quite radical. Now, you know, what can you do in a 45-minute? After you've taken attendance, you know, and after, you move to your next, so there's not really very much time to do much thoughtful mathematics. So we had to negotiate extended class periods to do the math, which we said can't do anything unless we have an hour and a half. This was way before block scheduling was there. So we need an hour and a half. And we need an hour and a half at least 2 days in a row, and then maybe another day you can just give me a regular 45-minute period, where we wrap up. And so these are the kinds of things we negotiated, how many times we would go in, and what we called our work problem solving, because we were trying to deal with mathematical ideas that were not yet introduced in the classroom. And we just branched everything into the problem solving. So if they were students in third grade, they'd be doing at least fourth grade work. And we would be giving them investigations that involved mathematics they had not been taught yet in schools and regular classrooms, however they taught them. So we did this in classrooms, and later we did them after school, where the students came and volunteered after school time. Can't get in classrooms in high school to do work like this. We use videos to capture students' work. In the whole classroom, we always had, not always, mostly, sometimes the camera didn't work, we had 3 cameras. And we had, besides, the videographer, we had a sound person. And the idea was to attend to the details. If it were a small group, or a small group interview, we would have 2 cameras, one that would focus on the written work of students, and another that would focus on the interactions of the students. So we wanted the videos to capture what the students did, built, said, wrote, and drew. And we also always had graduate students, researchers, and we collected the written work of students. So we had a collection of metadata along with the video data, and all the video data that I'm using to talk about has been transcribed in detail and verified by a researcher. So what did we do when we went to work with a session of students? We, the teacher researchers. We invited the students to explore. We gave them problems. We asked them to deal with the meaning of the problem, the sense making, and to provide justifications of solutions. What we did is we tried our best to pay attention to the developing ideas of the students. We encouraged sharing. On the basis of what we were doing, we had to design new tasks. All the tasks were tasks we designed, and we built on what we were learning. And as we moved along, we were doing analysis of data. Now, in our task design, we had several problem strands. And the strands were algebra, fractions and rational numbers, counting, probability, and pre-calculus calculus. Our approach to working on the problems was not working from simple ideas in an atomistic way to build up. Rather, our approach was to deal with something that was more complex, from which the simple ideas would emerge. So, for example, you see, if you want to explore some of the videos, that one of the problems would be the pizza problem. How many pizzas can you make when you can select from 4 toppings available? When our students worked on that problem, they worked first on the pizza with halves. They wanted to allow toppings on halves. So that's a hard problem. But the simple problem took them 5 minutes to solve. Now, if you start the other way around, the simple problem will take you 45 minutes to solve for some of our students. So we try to go with the complex from which the simple naturally, why spend time on the simple cases? So the conditions, again, to summarize, we were interested in having our students freely to collaborate, to work with each other, to freely move around in groups, to investigate what the ideas were of the others. This was very unusual. This is the time when students were sitting in classrooms and weren't supposed to ever leave their seats. We were trying to get them to move, to physically get up and move and become active in the classroom. Time was important, and we guided the time by what our observations were. And so if students needed more time, we just provided more time. Next time they came in, we gave them more time. We also provided opportunities to revisit earlier ideas and earlier solutions they built, and then we gave new tasks so that they could extend the ideas and, if necessary, make some connections. What were some of the questions we were asking ourselves? When we first started, our first and most important question was, how do mathematical ideas develop in learners? These are ideas that are not explicitly taught, ideas that they would be introduced through problem solving. We were interested in what heuristics and strategies they used to build solutions to their problems, what forms of reasoning they used to support their ideas, and then we were interested in how durable those ideas were. Over the years, could they go back, could they fall back, could they revisit problems, and what did they remember that was really important? So what did we learn? We saw very early that very natural way students use certain heuristics in their problem solving. They used guess and check, they controlled for variables, they looked for patterns, they thought of simple problems. This sounds like Paulier, doesn't it? We're supposed to be teaching these kind of problem solving heuristics. as Paulier had suggested, but these students were doing this in a natural way. They weren't taught to do them. They were just doing them. We were observing their use of these heuristics. We were observing them working to make sense. We also saw them very often making conjectures and testing them, seeing about and arguing about them. But the arguing was I think, a very refreshing, good, healthy argument. The arguments were something we were very pleased to see. So we learned that their forms of reasoning were natural. They built arguments by cases, by induction. They gave counterexamples to disprove. They have an upper-lower bound argument that I think I'm going to show you at the end. A little fourth grader building that argument. And they were using inductive reasoning. Some of the students in the seminar asked about the formal notation. We found that students very, very naturally invented their own notations to express their ideas. Very interesting notations. Some of them look a lot like the formal ones, but they don't all look that way. But what they were able to do is they were able to map their personal notations into more formal notations. And then when they were able to develop these formal notations, they were able to have now a very important tool of being able to generalize their ideas. And generalizing their ideas was really, really very exciting to see, because they could fold back again and revisit the earlier ideas. So they can go to the general and they can go back to the particular and move back and forth. Well, we found that new ideas came from their doing of mathematics. In the process of doing mathematics, new ideas came up. They developed from the old ideas. They were able to connect these ideas, the old and the new, the existing ideas. And when these were meaningful to them, these ideas were durable. And they liked doing it. We have wonderful videos when they didn't want to leave working on these sessions. They'd say, oh, you have to go back to class. They would go, oh, can we please stay? Or we don't want to go to lunch. Or, really wonderfully, they were so engaged, they didn't want to stop, and they enjoyed it. So this kind of really engaged learning is enjoyable, and that's important to remember. The students were the, I guess, the authorities in their learning, and they liked doing it. What we've done is we have, as a result of this large video collection, we have built a teaching portal. And this portal has certain tools that are analytic. We have worked with the university libraries, digital libraries, to build these ontologies and personal spaces to work, where it can support individual work and other collaboration. The Video Mosaic Collaborative is going to make, it is being instructed as we speak, to make available this unique video collection. We have already about 4,500 hours of video data that we've collected over the years. That's a lot of video. Now, the video we collected earlier had to be, again, recaptured and digitized with our more modern equipment. Apparently it's a very expensive piece of equipment that was purchased for the jazz school at Rutgers. And so everything we've already captured is being recaptured with the newer equipment to be prepared for the repository. Out of the collection so far, we have over 45 doctoral dissertations. And why those dissertations are so important, that's why this is collaborative work with my student colleagues, is because they have worked really hard at the very minute detail of those videos and the transcriptions and so forth. So all the videos that we have are accompanied with transcripts, and these transcripts have all been verified by another student, and their names are all in the repository forever, so we're very careful at doing this verification. So this is important because, the sound always is not perfect, and if you're not sure what the student said, at least you could say, you could go look at the transcript and follow it. We have also the student work. We have all of the metadata that comes with it. We have descriptions, and I'll talk about that later. Why do I think this is hopeful, and why do I think this is important? The Video Mosaic Collaborative, the intent is to produce this interactive digital environment. And this becomes a new tool to support video-based education for teachers, both for those preparing to be teachers and those in the field. That's very important because those preparing to be teachers don't have those images or the experience. They haven't been in classrooms except their own, and they have experienced the kind of learning they've experienced when they were going through schools. and they need more than that. They need to see other examples and ways that students do and learn mathematics. Our collection involves children doing mathematics at elementary, middle, and secondary levels. We actually have continued to collect data when the students were in college, but we're not funded to work on that data. The data we're funded to work on at the moment is all the elementary through high school, but we have quite a large collection of the data which is post-secondary. And so the collection can also be used for areas other than mathematics education, we believe, to maximize its use. There are some students who are looking at language and linguistics and how that is involved in learning. There are some students who are looking at the nature of the collaborations. So there are other things to look at that one might choose to study. Those folks in the learning sciences have become very interested in our collection in recent years. We're also very lucky because the Rutgers Libraries has other funding to develop this Rutgers Community Repository, this RU Core. The idea here is to preserve the work and research of faculty members. So if you go to RU Core, not just to our collection and our work with the libraries, you can see how a professor who's studying butterflies, how some videos that represent his work or the work of others. There's work in engineering and also as part of this RU Core repository. So other sources of funding besides what we have from the National Science Foundation has helped to create a tool that is able to be used in a more expansive way. And I'll talk about that in a minute. So it's not just mathematics education, but it can support other disciplines as well. So just in summary, what does our VMC do? For us, it preserves our video collection. I'm told it's going to preserve it for over 100 years. Now, that's pretty amazing, right? I'd be happy if it preserved it for another 20, 25 years, but it's, they say claim 100 years. It provides for sharing video data and metadata. It provides resources for people who are teacher educators who may want to have these images to show the teachers they're working with. Offers tools actually for teachers and encourages collaborative research. So we see that the potential of this Video Mosaic Collaborative is great. So I have some images here that I put in, but now I'm going to be very brave and I'm going to actually go to the website. If you look at teacher educators here, for example, for instance, suppose you wanted to follow fourth grade students, and suppose you wanted to look at their, I'm not worried about a tool. Let's see. Select a math problem. Maybe they wanted to compare fractions, right? And so that would be, let's say, in fraction strand. So if you wanted to search for this, certain videos will come up here, and you could actually decide what of those videos you want to study. Now, in the videos, there are certain members of the community that are subjects, and some of those subjects we followed for many, many, many years. So you could trace the learning of, let's say you want to follow Alan, you can follow Alan, and you can follow Jeff, you can follow Stephanie, from early grades all the way up within a particular strand. But for now, you can actually take a look at a particular video clip. It tells you what the problem would be. It would actually, you have a choice of using either a flash video or a QuickTime video. You can download the transcript as a PDF file. And you also have here a description of the particular video event. So it tells you when it took place, it tells you a little bit what's happening here, it tells you what tools are used, what strands, it tells you who else is in the video, what other students in the class are there, if you want to track some other students. And you can imagine the amount of work. I mean, the library group has worked on developing very, very detailed ways of inputting these data and having some very interesting ways of searching for it. Do you have any questions about this? So, I think, you need to get here and play, and it sort of suggests for NCTM, what are their standards, and in terms of their standards, what standards are met in this video: problem solving, reasoning improved, communication, connections, representation, etc. And so it's a little bit about that sort of thing. So that would be one example. Now I've got to go back home. I'm going to not leave here. So suppose you were interested in this notion of research and students. What's very exciting here is that there are some new tools that have been built for this repository. Now, just think for a moment, those of you who like to play with programs where you're doing writing or you like to do cutting and pasting. In my own writing, I do a lot of cutting and pasting, moving things around when I'm composing something. I imagine you do that too, using Word or some program. Now imagine that you are studying the development of some particular idea of some student, and you have found a series of clips. Okay, imagine that. Now there's going to be a tool that you actually can take this event, one clip, another event, another clip, another event, another clip, and you can put them all together to create a brand new event, which would be the union of those clips. You write your own description about what story is being told, what narrative is being told here. So you can imagine doing this if you're preparing professional development workshops, if you're a teacher educator. You can imagine a teacher in school who's maybe trying to work with colleagues or try to show how students are learning a particular idea. So this new tool, this analytic is something that's coming out of this repository that to me is very, very exciting. So again, I'll let you play with this later. Let's talk a little bit about teachers here. So here, you can actually working teachers have particular questions. They ask questions. Is it better for a student to be given the independent space to learn a concept like counting or working in groups and so on and so forth? They would have their questions, and they would have an opportunity to just have a discussion and post their ideas about it, and actually to post some videos. It becomes almost a workspace for those teachers. The research tool is really exciting for me, for my own work with my own graduate students, because in the courses I teach, they're able to create these analytics that are able to show a point they're making. They can actually show this with a video. All of the dissertation research that was done with all these videos, those videos, the full videos have been put into the Video Mosaic Collaborative. We don't make the 1.5 hour videos available because we can't really downstream them yet. We have to see if as technology improves, we'll probably be able to do that in the future. But whenever we put in pieces of video, as we chunk them so that you can download them, we put in the full transcript and the full video for future use. So if people want to go back and study again what's been studied, but from a different lens, a different perspective, or different research questions, they could go back and do it. All of the dissertations are also downloaded as part of this. So you can actually view the dissertations and the dissertations that are part of this. So that's really very exciting. So what is this tool? It's an analysis tool for education. It's flexible to serve many purposes. It uses an open source repository architecture, which is really important, so that only specialized people can come in. And the idea is to transform the environment to a space that is collaborative, where people can work together, whether they're teachers or teacher educators or researchers. Why do I think this is important? I think this is important because it provides an opportunity in a space to collaborate. I don't know what you've observed, but we as professors have observed our students are really far more technologically educated and talented than generations before. I mean, you naturally go right to the web and you look up information very easily, and you try to find resources, and you do that very easily. Now, the notion of trying to make this available for actual people who are isolated, or teachers, or people who are not able to be part of communities, to develop these online communities. I mean, look at the web communities that have been formed so far, right, like Facebook. It's very powerful. So why not have a learning community that's like that? We also, I believe that if you can talk about something, if you can talk about learning in a certain way, or read an article, to make it come alive, to show the video that produced that article, so that you can make your own decision, you could have your own questions, you could build your own meaning, right? And it's not that someone's telling you how to think about it, you now can think about it from your own perspective and from your own lens. I think that's very important. Also, what's important is that whatever data we've collected over the years, it could be reviewed, it could be ongoing, it could be, the question came about replicability in the seminar. Teachers can try to replicate some of these activities and investigations in their own classroom. Then they could deposit analytics. They might even be able to, in modified lesson studies, collect their own videos of them. So that there are resources here that can be used that are linked to the videos or to new videos. Again, it's not just the videos. Related to this is student work we've collected, those transcripts, our field notes, and the related publications. Whatever's been written and published about these videos and work are also linked into the MC. So the builders of the architecture here are very excited about the software, and that it's extensible, and that it could be linked to other domains using video as well. So the architecture is what they call, the community space is very flexible. All of this, by the way, is online if you want to look at it. So I said about this, I talked a little bit about the tool functionalities. When I look at this analytic model here, what you need to be thinking about is each of these units are the events that are put in, the video events, how they could be combined, and combined to create new events that we're calling an analytic. That's how the ideas grow. So the information object in its own right is everything that gets in there is copyright protected. It's like it's a published item. Once it goes in there, it's in forever. Once a video goes in, it has a number or some kind of a record that you can, if you're writing a paper and you want to relate to that video, you could actually link. And think about all the online publication that's taking place today. Wouldn't it be nice as you're reading the article that you could link to the video? There's been some work done in that regard already. So it really gives you an example to question, to investigate, to look deeper, okay? And it combines whatever the video we have to other related work, dissertations and so forth. And this is what they call their meta object. I don't want to spend time talking about this because we looked at that a little bit, but I want to talk about how we're using this tool right now as we're developing it. And Dan said earlier that my interest of the last 2 decades to look at learning of mathematics is now shifting to teachers, about teachers learning about students learning. So as part of our current work, we're involved in design research and collaboration with the University of Wisconsin. And in our design research, the big question that we're asking is, if we choose these videos that actually display certain kinds of ways students reason, will the teachers be better able to recognize students' reasoning by studying these videos? by looking at videos. So we have done a series of interventions, both for pre-service and in-service teachers. Pre-service teachers would be people like many of you in this audience, those of you who maybe think you might want to be teachers, you're undergraduates, and so you would be part of the intervention, and we would be interested in, before our intervention, if you look at the videos, what are you noticing about the kinds of arguments, the forms of arguments of the children? And then we spend time, analyzing other videos and showing you the different kinds of ways students reasoning and look to see if there's any growth. We also are interested in seeing if by watching what children can do very carefully in the way they reason, does that change some of your beliefs about what children can do as well? And we're also interested in some of your own knowledge about reasoning and how that changes over time. So, preliminary results we have, my husband's done some analysis for us from this is design research, so there are several iterations, and so we did some work in in-service, and our in-service model is a little different than our pre-service model, because our in-service model, we have cycles of interventions with in-service teachers, but within the cycle they have a chance to go into their own classrooms, and they actually present their own students with investigations, and they have the students write about their reasoning, then they analyze that reasoning. And what's very interesting and very encouraging to us, there's been a lot of growth in the in-service teachers in terms of recognizing certain forms of reasoning of students. So on the average, the growth was from pre to post assessments, almost 60%, and according to argument type, you can see that is really pretty encouraging. For pre-service teachers, there's also evidence of growth, and it's not as dramatic as the in-service teachers, and I explained that partially as they didn't have a chance to actually work directly with students, and the intervention was of a shorter time. This was done within classes where the instructor said, okay, you can have 3 weeks for your intervention. That's rather different than when you could, spread it out over a longer time with in-service teachers. So time is another factor. And we look at how they came in. I mean, they came in knowing something about these reasonings, so they must have learned something in their mathematics over the years, but they even grew more in recognizing what children were able to do. And it's kind of interesting because we did have a control class or a comparison class, and you can see there really was virtually no growth with the comparison class when there was no intervention. So that's sort of encouraging to us. So none of the comparison group produced either an argument by contradiction or any generalized argument. And so we can summarize this in the table here. You can see the in-service group, experimental, and the pre-service comparison. So the in-service teachers really had pretty dramatic growth in this particular district. This is Freehold, New Jersey, actually. Half of the teachers who were part of this intervention actually were special ed teachers. And folks are saying special ed teachers, teach by rote and they don't really believe kids can reason and think. Well, we found that to be not the case. They were as engaged in the intervention as the regular classroom teachers, and were very, very much influenced by studying the videos of the children. So that was encouraging. So, what have we done so far? We've established this VMC collaborative that we're building right now. We're trying to make the collection available worldwide. We are adding to the big repository that's being built at Rutgers University. And we're now conducting systematic design research with teachers in pre and in-service. Our design research in pre-service includes elementary and high school. Our design research in-service includes elementary and middle school. And so we have collected lots and lots of data that is being coded and scored, and we're in the process of working on it now. So what are some of our challenges? Well, people need to take the time to view the videos. We're trying to make the clips short enough so that they'll do it. We're inviting people to do related research. We're trying to recruit users of the collaborative, so we hope you're going to go online and look at this and keep watching as we keep ingesting more and more videos into our repository. We have lots of them waiting to go in. I think 50 are waiting to go in. It's a lot of work to put them in. We hope that the videos will have an effect on instruction, where teachers will now pay attention to student reasoning, encourage student reasoning, and notice it when it's occurring, and notice when the reasoning is correct, and be aware when the reasoning is maybe not so good, and so that it could build on and share earlier work. So this is the website. If you want to jot it down, please feel free to visit it at your leisure. But it's a work in progress, and every week it looks a little bit different. And if you can't get on sometimes, that means it's taken down because we're doing more work on it. I want to thank all the people who work on this project from a variety of universities. We have 3 universities where we're doing the research: Felician College, Seton Hall, and Rutgers University. And we actually have 8 school districts where we're doing the research in New Jersey. And with the 8 school districts, we're now collecting data from comparison groups as well. So that's it. Thank you very much. We want teachers to see student reasoning, to be able to understand that children reason really amazingly well. And we want them to see these existence proofs of the many, many videos that we're putting in of how well students reason and build mathematical ideas. And then the hope, of course, then is that maybe they'll be paying more attention to their own students' reasoning. Now,
how would that change their instruction, or how would that change math instruction? What's the alternative to what we're doing now?
Well, I doubt very much that teachers who believe children can do this powerful mathematics, if they knew that, would teach as if they didn't know it. I mean, I think that teachers who can respect and understand the powerful ways students can think and reason would have to pay more attention to it. That's my hope. Now, we can do professional development that can help do that, but I don't know where all that funding is going to come from to do it, unless we do it on some kind of scale that is not going to cost any more money. But at least it's out there for them to see what's possible. That not only are the videos here, but the strands of tasks that were developed and the problems that were there, and we tell them what the tools are and so forth. I mean, it would be that you have to be motivated to want to do it, of course. I think that, but there's the shift in just, I'm going to tell you how to do it, and of course students aren't learning how to do it by the teacher telling them many times, so that maybe teachers have to rethink that telling isn't the best model for instruction. But what is really important in mathematics learning? Isn't it reasoning? Isn't the ability to form a good argument or to build meaning about the mathematical idea? What is really important in what you think about what you've learned in mathematics over the years? Well, what is really important for adult citizens who are not, I'm saying, pursuing the study of math, although I think reasoning is good for them too. So that's my hope. Now, is there a direct link? No, I don't have a magic pill to tell you that it's going to solve all the problems of the road instruction. But I hope that teachers will know that other things are possible for a variety of children in a variety of settings. Okay. Satisfied your question?
I know a professor at CSUN at Northridge who's involved with Fulbright work in Rwanda, and she's working with rebuilding the math department at the University of Kigali. And what she's looking for is some type of online tool that she can use to help do teacher training, because there's a huge problem with people leaving the University of Kigali once they accredited.
Right.
And so I think that one of the problems that this addresses, which you put in your initial slide, is that teacher training isolation, that there really isn't a lot of frameworks for teachers communicating with each other. And so this seems like a breakthrough in teacher training.
I think that, thank you for mentioning that. I would like to think, I mean, I've done work in South Africa and Mozambique as well. And they are very isolated, and they look for ways to collaborate, to send them this information. But yes, you can develop these spaces for which to work and share ideas, these online communities. I'm hopeful that that's going to be an answer in the future. And I don't think, a community has to be a community of the people you work with in, your school. I belong to communities of people who are all over the world, and we collaborate. Maybe you may have something more in common with someone at another institution other than your own, where you can share ideas and collaborate. We know faculty do this all the time. Why not let teachers do this? Why not encourage them to use tools like this and to build? I think they have things they learned that they could share and add, because they have other knowledge, especially in places where maybe conditions are different and the same kinds of solutions don't apply anymore. So thank you. Yes, sir.
I went to a talk on this campus about 5 years ago by a psychologist from UCLA. And he was taking a lot of videos in classrooms across the world and so on. And he made the following point. A lot of schools graduates who go, say, into the Cal State system fail the math test and have to take classes in math before they start anything else. And the same with the community colleges. Something like 80% of the entrants into community colleges fail that test. And his remark was that a lot of these students just do not understand the written question that is on the mathematics page, on the page of the mathematics test. They can do the manipulation when the question is asked verbally, but they don't understand the language in which it's asked. Is that something that resonates with you in any way?
Well, I'm sure that's certainly the case in many situations where students don't understand the question, of course. But I think that's sort of not where I'm coming from. You mean Jim Stigler from UCLA? Yeah.
I don't know.
And I know his work. And I think we should be asking a different question. What kind of tests are we giving, and what do we want students to be able to do? They could work maybe with, as you say, the manipulation and whatever. But is that enough? Do they understand the meaning behind it? What understanding? I don't know that we have tests that get at that really well. But I doubt very much that these students who maybe even have trouble reading have had a chance to build a meaning behind the ideas. That's what worries me more.
Well,
So,
I mean, the examples he gave, the students knew the meaning when the meaning was explained differently. When the question was,
So that's a problem in the test construction.
that's a question in how the test was given.
So do you think that part of our big problem in testing in our nation today has to do, with these tests that we build and make? I understand that one of my grad students wrote all the questions for ETS's test. One person wrote all those questions. Wow, I would hate to have that as a burden for myself, my writing all those questions. Who writes those questions, right? What kind of expertise goes into them? What do people think about in writing them? Who decides what's important in those questions? And yet, these are high-stakes tests, aren't they? For a lot of folks. I've asked the question even to my own colleagues at the university, is that, okay, so we test the students, we find out that 80, whatever percentage it is, really don't meet our standard on our test. So I'm going to be a little controversial here. So we do some kind of an intervention with them. Do we ever test them afterwards with the same test to see if now they do? Or do we just do the intervention, now they pass the course, and we make the assumption they now know it? I mean, I don't think, I've not seen anyone follow through on that research, you know? We can say what they can't do, but we can't say what they can do afterwards, because I wonder how much different we're doing what we've done before. You know, how are we really focusing on what really is important here? So I don't know. I think it's very complicated.
I have three questions,
Yes.
Andre, Stacy, and Lee.
Yeah, quickly, it goes back to the title. I guess a lot of what I expected to hear was the way you prefaced the talk, which is a kind of historical talk. You got a longitudinal study, you got decline, I think, in the title, and then you prefaced by saying, you know, something's gone wrong, we're off the rails, and then, but most of the talk was about the tool itself. And I guess I'd like to hear you reflect more on what you were saying at the very beginning of the talk. And in passing, during the talk, I think you said, you know, we've got national state standards, and we're fine with that, or we're in line with that. But it seemed like at the beginning you were saying the standards are a problem. So if you could just reflect on what all this means for our
Well, I hope I didn't
state.
say standards are
Okay.
a problem,
All right.
because I don't think standards are a
Yeah,
problem.
maybe I misunderstood. It seemed like at the beginning you were talking about the constriction of the classroom and how things had changed so much and something had gone wrong. People didn't have the same freedoms. So just maybe if you could just reflect historically on what you've seen, reflect on what all this means.
Because that's almost another talk, but I'll
Yeah.
give it a try. So usually I try to spend some time giving examples of how students' reasoning is pretty sophisticated and amazing when they're not taught how to do this under certain conditions. And they do this at a very young age. And I didn't do that this time because if you're interested in knowing that, you could go look at the videos yourself, and the seminar students did that. They had a chance to study at least some sample videos that we picked. I did that in the context with the assumption that it is pretty well known that there is very little reasoning done in schools today. I take that as a given. I take it as a given that instruction in schools follows, you know, day-to-day programs of textbooks and all and rules, and students are told how to do certain things, and then they practice, and they come back, they do the homework, and it goes on. I take as a given that there is not reasoning that's taking place in schools. So I talk about the demise of reasoning. At the same time, I'm saying that over the last couple of decades, I've accumulated lots and lots of evidence in a variety of contexts, in poor schools, and wealthy schools, and working class communities, where over and over again I capture this incredible reasoning of students when they have an opportunity to investigate mathematics under certain conditions. And those conditions I think are really important. You know, I've listed what some of them are, but I also will emphasize now they're also safe conditions. They're conditions where they're part of a community where all ideas are welcome and shared and not judged and evaluated and graded. But they have a chance to think about what they're saying and understand it and get feedback from each other, peers, including, you know, the teacher who the teacher is. And then we found, and I have, again, 4,500 hours of video to document that their reasoning is pretty impressive, but yet it's not going on in schools. So I'm saying, why is that? Why is that happening? Well, we could say it's happening, we can blame lots of things, right? We could find lots of causes for this if we want to. Major one, is, people say, well, it's testing. And we do know that because of the pressure on testing, we know that teachers are teaching for the test. When they're teaching for the test, they don't have time to have students explore and investigate. That takes too much time. Well, of course, we keep saying time, but students are still not doing well in those tests. I will point out, by the way, that we did over 3 years of study of these students and their standardized test scores, and they continue to improve in problem solving and conceptual understanding, even though we never were teaching a computation curriculum. Their computation didn't decline. And so what I'm suggesting here is that how do we get people to understand that students really, in a very natural way, know how to think and reason? They do this in an incredible way. We as parents see our own children doing this, and our grandchildren doing it, and yet they go to school and suddenly they're not expected to anymore. They start to dislike math. They say they can't do math. And they say they can't do math. And adults who are very bright and intelligent and successful, but not math, that's ridiculous. I mean, think about it. It's ridiculous. So why is it ridiculous? Because we haven't helped empower them to believe that they are really capable of reasoning and understanding other people's ideas and contributing to doing, successful problem solving. So what I'm saying is that there is the demise of reasoning. I don't know, maybe there are shifts, I'm not a historian. I can talk about what I've observed over the last 3 decades of my work, but it's gotten worse. And it's not good at all today. And it's, maybe there are certain isolated places where you can say there are nice things happening, of course there are, but overall it's not a pretty picture. And is this good? I mean, those of you who teach mathematics at the college level aren't happy. Your students are coming and not, I don't know if you're finding brilliant students, but are they really able to reason well? Or are they able to do what you tell them to do and show them to do and practice for the test and then go on to the next thing? It all breaks down at some point. Even math majors breaks down at some point if they haven't built an understanding and reasoning foundation to support it. It may break down a little later than for other people. Graduate students, it may break down a little later. Maybe the PhD students, it breaks down even later yet. But you know, knowledge has to have a good, strong foundation. And that is based upon your natural ability to reason and make sense of situations, not just math, I think. But I have evidence to show in math. So that's why I did the title. Hope that's okay. Who's next?
I have I guess a historical question. You said your work was in alignment with the standards, but if you look at the National Council of Teachers' NCTM standards, they actually, a lot of the proof and reasoning, the discussion of what we should be aiming for is based on your work, actually. I think that you were very important in that, in that showing many of us that young children can engage in sophisticated reasoning. And I'm wondering, because us who came after you as researchers in method, we got to build on what you showed us, these visions of what children were capable of. But I don't know, I think I'm wondering, what was the impetus for you guys going in and giving children these opportunities that were absolutely atypical school experience? What led that?
That's a good question, and thank you for saying those things. That's really very nice. But when I started as a math teacher, when I was teaching mathematics at the undergraduate level, I was so disturbed that students wouldn't want to think about the solution. They wanted to know what the formula was, what was the rule. I was teaching courses in finite math and counting, probability stuff, and they just tell us what the rules are. But, we don't need to know why. And I know that they would only engage, if they only try to think it through, they would be able to build it, and it was really a struggle for me to try to, create situations to try to get them engaged, and I started to think, well, when did this start to happen? I was a high school teacher, I was a college teacher, when did this start to happen? I didn't know much about the younger children. So in my research, I kept going lower with my own students, lower, and I noticed that the young children engaged right away. Some of you said this in the seminar, and someone pointed out that as a young child, you were naturally engaged. You were doing things. You had tools available. You were encouraged, to collaborate and build models or whatever it is to do your problems. Then something happened. Something happened. I think partly what happened is that I think the teachers didn't understand the mathematics that they were expected to teach when the mathematics got a little harder. And so they had to teach it by rules. I think that's part of it. Part of it is, and so, it's very frightening. Even at professional development workshops, teachers are embarrassed that someone's going to find out that maybe they don't know something. Can you imagine how horrible that is for a teacher? It's bad enough how the community teacher bashes as it is. Think about how awful that is. So I noticed that it started to break down, when it started to get to be, teaching of fractions. That's why I went into a 4th grade class for a year myself. And they were teaching rules, and they didn't understand why these rules worked. Now I'm finding that, children are inventing these rules and not even being taught. They're inventing rules of comparing fractions. They're looking at ideas of density of fractions. That's the video I'm going to show you. They can do arguments of upper and lower. These are little 9 and 10-year-olds, can do these things. Teachers didn't know any of this, and the teachers were learning by watching the kids. So I'm thinking that this is the hope for that maybe teachers can learn by watching the children. that's not threatening, that's not in a group where they could be exposed for not knowing something they think they're supposed to know. Some of them are lucky, they can go get another degree, they can get a good teacher professional development project as part of somebody's grant or whatever. But what about all the others out there? Some of you and the seminar students asked me that question. Well, I'm hoping that maybe if we can, this tool, other tools of the next generation developing, we can make these wonderful findings public so they could learn. A lot of people learn on their own. How many of you learn on your own? You go off on your own, you do your own research, and you can explore, and maybe you could talk to somebody about it. I don't know if that answers your question. But that's sort of myself. I hadn't figured it out myself, and I was really very discouraged about what I was learning about. So it was, a lifelong experience.
We'll take one more question here, and then there'll be time for continued questions at the reception outside. Lee?
That is tremendous inventory, longitudinal data set, and ethnographic scan for anthropologists to think about that. With the teachers, we had a comparison group, and going back to students, by the way, how many students were in this group that you followed longitudinal? I didn't get that.
Depends on how you count. It depends on how you count.
Well, give me
So I'm saying that,
Give me a middle number.
I would say, it really does depend upon how you count, but 12, 14 students. Because some students left us and new ones came in, who moved from the area, but we followed about 12 to 14 students.
Okay, now my major question really.
Small.
My other question really reflects something other people have asked in different ways. And I'm not sure that whether you did it or not. You did an intervention, and you made an assumption that collaborative learning is better than individual learning. Is there any, not with the teachers, but with students, was there ever any control group of students who were still using individual learning, the standard methods, whatever, that we have used in schools, and then some measurement of outcomes? Not necessarily math performance, but life and outcomes and so forth.
Okay,
Was there any comparison group is the question?
There was no comparison group. And there wasn't, that was one of the conditions, the invitation to collaborate. It wasn't a requirement. Sometimes students collaborated, sometimes they didn't collaborate. Sometimes they would work, you could see on the video of the students saying, wait, don't talk to me now, I want to think about this by myself. I'm not ready to hear what you're saying. So some of you saw that in Maria's book. Michael says, I'm not ready to hear what you're saying yet, or okay, now I'm ready. So this investigation was to see what was possible that students could do under certain conditions, and that was one that was available to them. They were not imposed conditions. Students were invited to do these, if they so choose. And no, that wasn't, but that's the work of the new generation to do. Try to look at some of these that look promising, and to try to come up with some good control comparison groups. That would be a very good study, I think, but no, we didn't do that.
Thank you very much.